in this example, we have given a graph of this function f over here, that red curve that you see. Our goal is to figure out these limits given over here, right, and then also the value of the function at -2 by just using the information that is available on this graph. So how can we work on this problem? Let's begin from the first questions here. On this equation, we need to find out the limit of the function f when x gets closer and closer to -2. And then since we have the plus sign over here, that means we need to go closer and closer to -2 from the right side. Okay, so that's what it means. That means find the right side limit of f. That's what it means, right? So at -2. So how can we find that? So since our goal is to find the limit of this function when x gets closer and closer to -2 from the right side, so -2 is somewhere over here, right? So we have a -2 is somewhere over here. Let's on the x-axis, let's get closer and closer to -2 from the right side. So whenever we go closer and closer to -2 from the right side on the x-axis, you can see the height of the curve, which is determined by this height over here. The height of the curve, you can see, is actually determined by this curve. So this is actually getting, or the y values on this curve is actually getting closer and closer to this location. Although we have a hole there, but when x value gets closer and closer to -2 from the right side, the y value is just getting closer and closer to that hole, and which is around somewhere over here at 2, right? So if that is the case, then the limit of this function when x gets closer and closer to -2 from the right side is exactly equal to 2. Okay, so by using the similar idea to find the limit of this function f of x when x gets closer and closer to -2, because of this superscript here, we need to go closer and closer to -2 from the left side. That means we need to find the left side limit of the function f of x. So how can we find that? By using a similar idea, now we need to go closer and closer to -2 from the left side of -2 on the x-axis. So whenever we go closer and closer to -2 from the left side, the height of the curve is determined by y values. So you can see here gradually it's like that, and then you can clearly see it's actually, we can just follow the path of this curve, because that's how it will determine the height of the curve, or the y value. It's just getting closer and closer to, again, whenever x is getting closer and closer to -2, the y value is just getting closer and closer to that hole, right? So if that is the case, and that hole is in the location of y equal to 2, so if that is the case, again the left side limit on this case is actually again equal to 2. Now our goal is to find the limit of the function as x gets closer and closer to -2, which is, by the definition, right, if we need to find out the limit of the function at some location, let's say at x equal to -2, then we go closer and closer to -2 from the left and then from the right on the x-axis, and then we see how the y value behaves. And then if the y value behave in the same way, like on this case, when x gets closer and closer to -2, either from the left or either from the right, so the y value is just getting closer and closer to this hole at the same location, which is y equal to 2. If that is the case, then the limit of this function at -2 is exactly equal to 2. Or you can just say, since the right side limit at -2 is 2 and then left side limit at -2 is 2, so they are same, so limit of the function at -2 is 2. To find the value of the function at -2, we don't look the behavior of the function when x gets closer and closer to -2, but what we look into is just see what is the height of the curve, let's say exactly at -2. Okay, and let's try to see what is happening over here. So let me just remove this thing over here. So exactly at -2, you can see the height of the curve is actually not determined by that location, because we have a hole there. That means the function is not defined. The y value, or the height of the curve on this case, actually determined by this solid dot, which is somewhere over here. That's the y value, right? What is that height? So if this is 4 and that is 6, so this must be at 5, right? So if that is the case, the value of the function at -2 is actually equal to 5. And this is how we find the left side limit, right side limit, limit of the function, and the value of the function. But remember here, this plus sign over here, the plus sign on the superscript here, and then negative sign on the superscript, they will determine the right side limit and the left side limit. The plus represents the right side limit, so we need to go closer and closer to -2 from the right side of the -2, and then when the negative means the left side limit, right? So that means we need to go closer and closer to -2 from the left side. All right.